Exams are around the corner, but if all that study and revision is making you feel too overwhelmed to continue, you definitely need to watch this program. Hi, I'm Arjun Bhagat and I welcome you once again to Topper's Exam Special. Together we'll trace exam trends, practice some probable questions and share some nifty exam tips. So join me to gain the Topper advantage.
Today we'll discuss the unit linear programming. This is a pretty important topic as it is worth 6 marks, that is 6% of your total question paper. The unit of linear programming comprises of only one chapter, namely linear programming. Ever since the beginning, CBSE has been asking a 6 marks question from this unit.
Observing trends gives you an idea of the kind of questions that will be asked in the paper. But doing a good revision is also very important. So let's do a recap of this unit now.
While preparing this unit, you should remember objective function, constraints, non-negativity constraints, feasible region fundamental theorem of linear programming, methods for finding optimal solutions.
These important points need your serious attention as a 6-mark question is expected from one of these topics. So revise them very carefully. Now the examiner will be looking out for certain types of abilities via these questions. So let's take a look at what they would be.
The questions from this unit test students on representational, conceptual, knowledge and numerical ability.
So it covers all your abilities. Don't worry, you just have to follow what we've been doing at Topper. Yes, you need to study smart. Now before we take any practice question, I want you to pay attention to this model question. It'll show you the ideal way of answering the questions based on linear programming.
In this model question, like in a typical diet problem, we need to determine the amount of different kinds of constituents which should be included in a diet so as to minimize the cost of the desired diet such that it contains a certain minimum amount of each constituent. For solving this question, we first have to formulate the linear programming problem and then plot the inequalities on the graph accurately. This will give us the feasible region. Primarily, your representative ability is being used and put to test in this question. So, let X units of food X and Y units of food Y be used. Then our problem is to minimize C is equal to 4x plus 3y subject to constraints. 200x plus 100y greater than or equal to 4000, which implies 2x plus y greater than or equal to 40. X plus 2y is greater than or equal to 50. 40x plus 40y is greater than or equal to 1400, which implies that x plus y is greater than or equal to 35. Using these constraints, we can find out the feasible region which is shown shaded. The table shows the corner points with the value of the objective function at each point. The minimum value, rupees 110, of the objective function is attained at the point I, 5, 30. Therefore, the cost C is minimum when x is equal to 5 units of A and y is equal to 30 units of B are combined in the diet. While plotting the graph, be careful to shade out the correct feasible region and also write the correct equation of each line.
You need to understand that getting 6 marks in a go is not an easy task. So you need to practice a whole lot. After all, practice makes perfect. So let's solve the first practice question for the day.
In this manufacturing problem, a company sells two different products, A and B. The two products are produced in a common production process, which has a total capacity of 500 man-hours. It takes 5 hours to produce a unit of A and 3 hours to produce a unit of B. The demand in the market shows that the maximum number of units of A that can be sold is 70, and that for B is 125. Profit on each unit of A is Rs 20 and that on B is Rs 15. Now you need to tell me how many units of A and B should be produced to maximize the profit. You have to solve it graphically. Let's get it solving. If the number of units of A be X and that of B be Y, then our problem is to maximize P is equal to 20X plus 15Y. Subject to the constraints X greater than or equal to 0, Y greater than or equal to 0, 5X plus 3Y less than or equal to 500, and X less than or equal to 70 and Y less than or equal to 125. This gives us the feasible region, which is shaded. Keep in mind that the feasible region is always a convex region. The corner points with the value of the objective function at each point are shown in the table below. Profit is maximum when X is equal to 25 and Y is equal to 125.
As we mentioned, most of the questions from linear programming test your representative ability, so you need to be really clear on how you present the graphs, as they are scoring and also the examiner can be impressed easily. Now let's move on to our next practice question, which is a probable question for your paper.
The second question is that if two tailors A and B earn Rs 150 and Rs 200 per day respectively, and if A can stitch 6 shirts and 4 pants per day, while B can stitch 10 shirts and 4 pants per day, so you are asked here to find that how many days shall each work if it is desired to produce at least 60 shirts and 32 pants at a minimum labor cost. You need to solve this problem graphically. Be careful while solving this question, as it is rated difficult on our difficulty meter. Let's see the answer now. Let the two tailors work for X days and Y days respectively. Then our problem is to minimize the objective function. C is equal to 150X plus 200Y. Subject to the constraints 6X plus 10Y greater than or equal to 60, which means 3X plus 5Y greater than or equal to 30, 4X plus 4Y greater than or equal to 32, which means X plus Y greater than or equal to 8, and X greater than or equal to 0, Y greater than or equal to 0. Here the feasible region is shown shaded, which is unbounded. The table of corner points and the objective function values is also shown. We can see that C is minimum equal to Rs 1350 at E 5, 3. This shows that when tailor A works for 5 days and tailor B works for 3 days, the labor cost is the least. Notice that if S is unbounded, then a maximum or a minimum value of the objective function may not exist. However, if it exists, it must occur at a corner point of S.
Isn't it interesting to know how you can solve real-life problems through linear programming? To practice more on this very interesting topic, you can visit our website www.topperlearning.com. Well, we've completed half of our session. Let's take a break. But coming up are more practice questions, a HOTS problem and special tips for you. But to keep you busy, I want you to solve this breaking question.
You need to maximize, if possible, z is equal to 3x plus 4y, subject to the constraints x minus y less than equal to minus 1, minus x plus y less than equal to 0, x greater than or equal to 0, and y greater than or equal to 0. So got the answer to what was asked before the break? You were supposed to maximize, if possible, z is equal to 3x plus 4y, subject to the constraints x minus y less than or equal to minus 1, minus x plus y less than or equal to 0, x greater than or equal to 0, and y greater than or equal to 0. As you can see on the screen that this region is infeasible. Therefore, no solution exists.
So that was a simple one, just that it needed a focused mind. Well, before the break, we solved a model question related to diet problem on linear programming and attempted practice questions based on manufacturing problems which are solved using linear programming. Now let's move on to our next practice question.
Here we are told that Anil wants to invest at most rupees 12,000 in bonds A and B. According to the rules, he has to invest at least rupees 2,000 in bond A and at least 4,000 in bond B. If the rate of interest on bond A is 8% per annum and on bond B it is 10% per annum, how should he invest the money for maximum interest? Solve the problem graphically. In this question, your representative ability will be tested, and to get to the answer, we proceed like this. Let Anil invest rupees X in bond A and rupees Y in bond B. Our problem is to maximize P is equal to 8x by 100 plus 10y by 100. Subject to the constraints x plus y less than or equal to 12,000, x greater than or equal to 2,000, y greater than or equal to 4,000, x greater than or equal to 0, y greater than or equal to 0. The non-negativity constraints are redundant because of the constraints x greater than or equal to 2,000 and y greater than or equal to 4,000. After plotting all these constraints on a graph, we can find the feasible region which is shown as shaded. The corner points and corresponding values of the objective function p are in the table. P is maximum rupees 1,160 when x is equal to 2,000 and y is equal to 10,000. That is, interest is maximum when investment in bond A is equal to 2,000 and investment in bond B is equal to 10,000.
These questions are based on previous exam trends, thus making them highly probable. I hope you're paying close attention. Coming up is the last practice question, after which we'll take up our HOTS question.
This problem states that a manufacturer plans to install some new machines in his workshop. Type A machine costs Rs 800 and occupies 3 square meters of floor space. Type B machine costs Rs 1600 and occupies 1.5 square meters of space. He can spend Rs 20,000 altogether and 30 square meters of floor space is available. Type A turns out 10 components per hour, whereas Type B 15 per hour. Trade restrictions compel him to avail at least 3 machines of Type A and 4 machines of Type B. You need to find out maximum number of machines he can install and tell that which arrangement gives him the maximum output. To find out the maximum number of machines, let us first assume that he buys X machines of Type A and Y machines of Type B. To find out the maximum number of machines, let us first assume that he buys X machines of Type A and Y machines of Type B, taking into account the cost of the machines and total money available. 800X plus 1600Y is less than or equal to 20,000. X plus 2Y is less than or equal to 25. Again, using the conditions of space available and the space required for the machines, X is greater than or equal to 3, Y is greater than or equal to 4. The number of machines he buys will be N is equal to X plus Y, and the total output O is equal to 10X plus 15Y per hour. By plotting all the constraints on the graph, we can shade out the feasible region. The table shows the corner points with corresponding values of the objective functions. At the point C, N and O are maximum. Thus, the maximum number of machines he can buy is 15. Also, the maximum output can be obtained by using 5 machines of Type A and 10 machines of Type B. The maximum or minimum solution of an objective function occurs at the vertex corner of the feasible region. If 2 corner points produce the maximum value of the objective function, then every point on the line segment joining these points will also give the same maximum value.
Now, as you know that in the newly designed paper, about 20% of the questions will assess HOTS. Yes, your high order thinking skills. Here's one such question. It's a difficult one, so you can't take it lightly.
In the HOTS question, we are told that a medical company has factories at 2 places, A and B. From these places, supply is made to each of its 3 agencies situated at P, Q and R. The monthly requirements of the agencies are, respectively, 40, 40 and 50 packets of medicines, while the production capacity of the factories A and B are 60 and 70 packets respectively. You can see the transportation costs per packet from the factory to the agencies on your screen. So you have to find that how many packets from each factory should be transported to each agency so that the cost of transportation is minimum. Also find the minimum cost. This equation is also based on conceptual ability, as it involves writing the given information as the equations, representing them as lines, and then finding the optimum solution. Here's the solution. From the factory at A, let X packets be transported to the agency at B and Y packets to the agency at Q. Clearly, 60 minus X minus Y packets will be transported to agency at R. Obviously, X greater than or equal to 0, Y greater than or equal to 0, 60 minus X minus Y greater than or equal to 0. Since the monthly requirements of the agency at P is 40 packets and X packets are transported from the factory at A, the remaining 40 minus X packets will have to be transported from the factory at B. Thus, 40 minus X is greater than or equal to 0. Similarly, 40 minus Y packets and 50 minus 60 minus X minus Y packets will have to be transported from the factory at B to the agencies at Q and R respectively. So, 40 minus Y is greater than or equal to 0 and 50 minus 60 minus X minus Y is greater than or equal to 0. Now, the objective function or the transportation cost is given by 5x plus 4y plus 3 into 60 minus x minus y plus 4 into 40 minus x plus 2 into 40 minus y plus 5 into x plus y minus 10 is equal to 3x plus 4y plus 370. Now our problem is to minimize C subject to the constraints. The shaded region is the feasible region. The corner points and the corresponding values of transportation cost are in this table. Thus, we find that C is minimum at the point 10, 0. Therefore, for the cost to be minimum, 10, 0 and 50 packets will be transported from the factory at A and 30, 40 and 0 packets will be transported from the factory at B to the agencies at P, Q and R respectively. In the tabular form, the number of packets to be transported is shown in the table. Minimum cost is given by C is equal to 3 into 10 plus 4 into 0 plus 370 is equal to 400. Do write the coordinates of each corner point of the feasible region. This is because even if your calculation of the value of objective function goes wrong, you will get some valuable marks for writing the coordinates of the points correctly.
So now you can log on to our website, that's www.topperlearning.com, and practice more questions. Just to remind you, practicing more questions will increase the probability of you getting those 6 marks quite easily. Now it's time to give you some nifty tips that might come in handy while solving questions in exams. So keep your eyes glued to the screen.
First, we'll talk about multiple optimal solutions. It is possible that you get the same minimum value or maximum value corresponding to 2 corner points, like you see in this table. In fact, in such cases, you will see that every point on the line segment joining those 2 corner points give the same minimum or maximum value. Then, find and show value of objective function at each point, even at those which you know cannot be the solution. This includes the origin when it is a corner point. When half planes of inequalities do not overlap, it results in infeasible region. Therefore, no solution exists. Most students use the corner point method to find the optimum solution, but there are some who also use the line method. I feel, however, the corner point method is more foolproof method. When using the corner point method, tabulate the points and the corresponding values of Z. That enables the examiner to see it all in one go. Also read your question carefully to see if it is asking for the optimum value of Z2 or only the corner point at which it is attained, and write your answer accordingly. And in your final answer, rather than giving values of X and Y, values of the corner point, use the language of the question.
That's all for today. As far as linear programming is concerned, we covered it completely. Now it's up to you. Prepare well, practice a lot, and always remember that time is important, so don't waste even a bit of it. On that note, I'll take your leave. Till we meet next time, keep studying smart. See you soon with another episode of Toppers Exam Special. Goodbye and good luck.